Okay, guys, discrete optimization, Knapsack algorithm. We're going to look at greedy algorithm again, okay, and this time in more detail. The key point here is that what we want to do is have something that can give you solutions very quickly, okay? And that's going to give you a baseline on everything that you will do afterwards, okay? So you can start with this, and then you can look at how to improve it later on, okay? So even greedy algorithm is an interesting topic, okay? Designing them may be very complex on some problems, and they may vary in quality. So what I'm going to do today is basically illustrate various kinds of greedy approach on the knapsack problems, and, you know, in a sense, give you the intuition of how you can design them. And you can be creative on these guys as well, okay? So the key idea on all the greedy algorithms is going to be the same. You're going to pick one item at a time in a greedy fashion. And the only thing that's going to differ is the meaning of greedy in every one of these algorithms, okay? So we call them greedy algorithm on heuristic, and you'll see why later on. I will tell you why we call them this. Okay, so once again, think about the temple is collapsing. We saw that in the previous lecture. You know the various items that you have. You know the value that each of them has. You also know the weight of them. And obviously, you know the capacity of your knapsack. Okay, so which item do we start taking? Okay, that's the basic idea. That's what we are trying to do. And this is the first thing that you can say, okay? So I'm going to take very small things because I believe that I can pack many of them, and then I'm going to give you a good value at the end, okay? This is the first idea. You look at the item, you sort them essentially by weight, and you start packing them, okay? So what you see there, you see the small weights at the beginning, higher weights until the very heavy mask over there. And so you start picking these various items, essentially until you exceed the capacity of your knapsack. At this point, essentially, you can't pack any more item, so you are fixed with what you have selected so far, and you get a particular value, in this particular case, 10 million. That's one greedy algorithm, and the greediness here was selecting the smaller item first, and you put them in until there is no space on the knapsack, okay? Very simple greedy algorithm. We saw another one, okay, during the previous lecture, and that was selecting the most valuable item first. Okay, so to remind you of what we did, we sorted the item by value, okay, starting with the mask and so on and so forth, okay, and then you pick the highest value item, and then immediately there are items that you cannot put inside the knapsack at this point because they are too big, and then we take some of these warriors, okay, in this particular case, one of them, to actually get the value of the knapsack in this particular case, which is 14 million here. Better solution in this particular case. The greediness was different here. It's not the smallest item, it was the most valuable item. That's the second idea of a greedy algorithm, okay? In this particular case, this one was better. You know, I can easily design a case where the first one would be better. Now, can we do better than these two? Okay, and I'm going to show you an interesting idea here because we are going to start focusing on the structure of the problem, okay? And you'll see in this class, structure is going to come back all the time, okay? Exploiting the structure of the problem. So when you look at this thing, one of the things you can do is that, okay, so most valuable item is interesting, but this may be very, very, very heavy. And the small one may have, you know, they may be tiny, 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 but they have no value, okay? What you want to do is really find something which is called value density, okay? How much value do you have per kilo that you will have to lift and transport, okay? So look at all these items. We know the value, you know the weight. You can divide these two things, and you get a sense on how, you know, what is the value of 1 kilo of this warrior, of 1 kilo of this mask, okay? And now you see that you can sort them by that order, and this becomes the most valuable, and then you see the ordering is changed completely. And now you start packing them inside this new ordering. Okay, so you put this particular artifact first, and as soon as you do that, you can't select the mask anymore. And then you put the tablet, and you get 8 kilos. So you still have some room to actually put a particular warrior there, and you get a value which is 18 millions. Okay, so here we exploited the structure. We really look at the value per weight unit, and we got a better solution in this particular case, okay? Now you may ask, is this the best we can do? Is this optimal? Is there any way I can improve? And obviously this class is going to be all about, you know, improving on the greedy algorithm. And in this particular case, they're very, very simple solution which does better. You select these 2 tablets and you get a value which is 20 million, okay? We still don't know if it's optimal, right? But in this particular case, we can actually prove this. So, in a sense, the main messages today is to show you that in practice, there are many different greedy algorithms that you can build. You have to think, creatively, what is the best greedy algorithm that I could get? And some will be better than others in different kinds of instances, okay? So, and so you may actually use several of them at the same time. The advantage of this is that they are very easy to use, very easy to design, okay? They can be very, very fast. They give you a first solution. They tell you, okay, now I understand something about these problems. I know that this is at least a baseline, and I have to start doing better than this. They have a lot of issues, obviously. Okay, so there is no solution guarantees in general. You don't know how much you can improve them. You don't know how good they are. The quality of these heuristics may vary from problems to problems, from instances to instances, and so on. And one of the things that I've assumed here is that you can build the solution easily. Finding a feasible solution is not an issue. And there are many problems in practice where just finding a feasible solution is very, very difficult. So you will have to do something else than a greedy algorithm in that particular case. Or you will have to change the notion of what a solution is. So, but these are some issues that we'll have to deal with once again. And these issues, the most advanced techniques that we will present in this class will address those. So, one of the things that you should do in this class is when you start on a problem, okay, what we highly recommend is that you start with a greedy algorithm. Try to understand what the problem is. Get a baseline. That's what you have to improve. And then afterwards, you're going to use some of the techniques that we will present, constraint programming, mixed integer programming, local search, to actually improve on the greedy and find out how much you can improve. And once again, some of these techniques are also going to give you a way to assess the value of the greedy algorithm or any solution that you can come up with. Okay? So this is essentially the main message. I'll see you next time, okay? And what we're going to do in the rest of the Knapsack lecture is show you how you can find reliability feasible solution, how you can build high quality solutions which are robust across a wide range of impact, and also give you a way to actually find out if these solutions are optimal or how good they are. Okay, this is essentially the most advanced techniques are allowing you to do these things that a greedy algorithm cannot. Okay, see you next time. Thank you, guys.